How many of you knew that Asus actually made network switches? You probably think that's cool. It's actually kind of tragic. I can promise you that this is just white-labeled garbage from Ali. In fact, I'm pretty certain that what Asus has done, and I'm not going to bother looking on Ali for this specific product, but if you go on Ali, you can probably find this switch, and they just slapped the label on it. In fact, Asus knows such a little about networking. Look at the way that they label the ports. 1, 2, 3, 4, 13, 14, 15, 16. Why is that wrong? Because each of these blocks go through their own magnetics. They go through their own transformers back to their switch chip, to the switch fabric, or whatever the CPU is inside of this thing, or switch chip, okay? So whoever designed this knows nothing about networking. Now, they decided to throw, a green tag on it to say, this is a green product, because that, at the time of the production of the switch, was the biggest thing, was green networking. Now, what's wrong with this switch, you might ask? You try to power it on, and I don't know if you can see that. Let me turn off the lights. See how the power light's blinking? That's because the bootstrap cap has failed in this power supply. Because it's a piece of garbage. So what do we got to do? Well, we got to fix it, yeah, but I mean, I would never use this stupid thing. Now you see what I mean? So you see these ports here go through these magnetics back to this chip. These ones here, this chip, this one here, this chip. And look, it's actually got room on here to accommodate 2 SFP cages. And it doesn't look like, it looks like I could probably literally dump the SFPs on here and they would work. This is a dumb switch. It is most definitely not a smart switch in any way. But, yeah, see? So now 1 to 4, 13 to 16 doesn't make sense at all to you guys. Now you understand why literally every network switch on the market goes 1, 2, 3, 4, 5, 6, 7, 8, and continues on. Because this grouping goes through these magnetics to this switch chip. Now what's wrong with this? Look at that dinky little power supply. Now, that's fine and all. It's all fine and dandy. But we've got a blown cap on here. And it is a... I believe it's a 50 ohm. It's the bootstrap cap. The bootstrap cap is fucked. Da-da-da-da-da, let's fix it. It's always a dead giveaway when you see shit doing that. There, caps are dead. Alright, so where is our little 50 ohm nightmare? It's right there. Actually, it's got more than that blown on it. We've got 1, 2 caps right here that are blown. These guys have vented, which means that they've overheated. Interesting. What is this power supply? It's probably a 12 volt, I'm willing to bet. Because the caps on here are rated at 16 volts. These are rated at 16 volts as well. So let's get a couple of capacitors. Alright, what do we got here? These are 1000 microfarad. What have I got? Do I have any 1000s? Don't shame me for recycling parts. We're in a part shortage right now. There's a 1035. If I can find a pair to that one. That'll actually be a little bit better suited. 1216. So it looks like I don't need the bootstrap cap. I just need to replace the 2 caps that, you know, bombed. Ooh, I was looking for one of these. Snap cap. So many capacitors, such a little time. See, these are all bootstrap caps here. I have various ones for this obvious reason. What's this one? 3300. Yeah, these ones are way too big. It probably won't work. Do I not have a second 1000? Wow, look at the difference in those. These have exactly the same rating, but look at the difference in size of them. Goes to show you the quality on these guys. These are Jamicons, and these guys are YC. I hope I've got another cap in here. I am grossly lacking capacitors of this specific rating. You know what? It's not a big deal. I might be able to scavenge one from somewhere, so hold on a second. Alright, turns out that these two caps are in parallel. And by the way, the bootstrap cap on here is 22 microfarads, 50 volts. I forgot. They're pretty much all the same on switching power supplies. So anyway, since we have figured out that these caps are in parallel, technically I could actually just put one that's rated for the same voltage but twice the capacity. Let's see if I can weigh this down and get these little guys out of here. I wish I had Thomas's wicked awesome solder sucker machine. It's pretty cool. I like putting a little bit of flux on my desoldering tape, by the way. And yeah, remember, you guys are all like, "Oh, Sarah's amazing with electronics." And I'm okay with power electronics. Thomas, my business partner, is the one who does all of the repairs for a reason. Because he is 10 times better at this stuff than I am. When it comes to little things like this, or fixing power supplies, or working on DC systems, that's kind of my thing. And the consulting, you know, the network engineering consulting stuff. When it comes to working on high-level electronic repairs, that is not me. Alright, so both of our negatives are facing it this way, so I'm just going to rip this guy out of here, and I'm just going to put one of these guys in instead, because it's got... one of these has the same rating as two of those. And by the way, this power supply is a piece of junk, as is the switch itself. I wonder if we can find any indicators of who actually produced this switch. And where's my wipey pad? That's not good. Probably need my nippy nips. Let me get them. There we go. We're gonna put this new capacitor in here, and hopefully this guy will fire back up. Move over MOV. Alright, there we go. One leg. There's two legs, and let's make sure that I get her in there nice and tight. Nice. Let's see if we still need the bootstrap cap replaced. The switch. And let's see if it'll power up. Yeah, it's pretty bad that this diode here has like been overheating like a mofo. I mean, that's not good quality. When something's overheating like that, that's typically not a good thing. Especially when it's not even being used for very much. So that makes me concerned about the actual safety of a device like this. I mean, especially with this crappy power supply in it. Now, typically when you've got a device like this, the power supplies are usually in their own little cage. Okay, so there'll be like a separate cage off to the side that has the power supply in it. Okay, and that's how they get their safety rating. This switch to me does not look like it actually has a safety rating. Yeah, I don't see a CSA or an Underwriters. I see CE, but I don't know. I don't like that at all. Okay, so let me just get this last screw in here. And if we're lucky, that cap would have fixed it, and I don't need to replace the bootstrap cap, which is tucked into a teeny tiny little spot, which will be a pain in the ass to get into. All right, here we go. Let's see if I explode. Which, look at that. It works. Ta-da. This horrible Asus switch is now working. And in fact, let's just validate that. Since I doubt that this thing has any kind of spanning tree intelligence at all. Looks like it works to me. Oh, it looks like it does have basic spanning tree intelligence. How clever is that? Yeah, it creates a loop, and then it disables the loop. I'm actually kind of impressed. Color me impressed. Well, there we go. We just fixed this shitty power supply, which was using two 16-volt, 1,000 microfarad caps in line, which essentially is 16 volts, 2,000 microfarads. And I popped in a 3,300 microfarad cap instead, and it's dead. So yeah, the switch is fixed. That's all there was to it. It's just literally replacing a bad capacitor. And usually when there's a problem with a power supply like that, and it is caps, that's when you will most certainly see the power light blinking on and off, and on and off, and on and off. That is usually a pretty good indicator that there's a bad capacitor in there somewhere. So there's another one of my repair items fixed. That somebody had sent to me for repair, which honestly wasn't worth it, but I said to everybody that there's going to be people out there who want to know how to fix their shitty Asus switches, and that's how you do it. But I am honestly surprised that this thing actually has basic spanning tree functionality built into it, because from what I'm seeing there, when this thing looped, it disabled the ports and indicated which ports the loop was present on. So even though this is an unmanaged switch, that's actually a pretty cool function. So even though this is a piece of garbage, in my opinion, especially with the build quality, hey, whatever. So there you go, guys. I have just fixed this Asus switch, and it took me a grand total of 10 minutes. And this isn't the first Asus switch that I fixed, by the way. The other one was bootstrap cap. Bootstrap cap popped, and it's the one that actually brings the circuit online. The switching power supply. So let's see here. So that's basically all she wrote. Hope you guys enjoyed that. Don't forget to like and subscribe. If you guys want to help feed me in this god-awful economy where everything's going to shit, please feel free to join the Patreon and keep me fed. All right? Don't forget to leave in the comments below what you thought, and if you have any suggestions for video content or want any elaboration, okay? Just leave that in the comments below. And if you want to dislike the video too, by the way, please leave a comment as to why the video sucked so that I know and don't make the same mistakes again in the future, okay? Why do I always lose a screw? How does that even happen? I'll have to go into my screw bin. Whatever. Alright, so there. Switch fixed. Bye.